I think one of the hardest things that any of us does is to be able to gain an accurate view of ourselves. So looking for ways that allow us to kind of drill down to the essence of how we think about things, what our values are, and how those values associate with the way that we do our science, in the case of scientists, is essential.
When you get ready to ask a scientific question, it's important to think about the kinds of problems that you like. And this is not just what kinds of biology do you like, because most biologists I know are pretty interested in a lot of different kinds of things. I feel like this has more to do with the kinds of experiments that you like to do or the sorts of ways that you like thinking about a problem.
And this is why I think graduate school is such an amazing thing, right? Like, I don't know many other careers where you get to spend 5 or 6 years figuring out what things you find really exciting, how you work best, what things you find really challenging, and then sort of being given the opportunity to overcome those things. The most important thing for me to realize was that I can be interested in pretty much any type of science as long as it has some visual component. So looking back over pretty much every project that I've done, it's had a big chunk of microscopy in it, which isn't surprising given that I also love to draw and paint, and I did photography, and I've done graphic design, and so I'm clearly like a visual thinker. And so the ability to do science by looking very carefully at things is really satisfying for me.
The project that I started in the second half of my postdoctoral career that I ended up basing my entire lab on came to me kind of fortuitously in the fact that there's somebody else in lab who was doing this really, really interesting technique. And I wanted to learn it, and that was it. I really wanted to learn this technique. It looked really challenging and really fun, and I felt like if I could master that technique, I would be incredibly proud of myself. And so I was in the process of performing a screen in Drosophila, and I began to focus specifically on kinases just so I could perform this one technique that had to do with kinases. And that's essentially how it happened. I was just so enthralled with this one method that was developed by the Showcat lab at UCSF that I just really wanted to learn it, and that was a huge motivation for me.
It's really important to recognize that you can gain those insights about yourself, not just by looking at your previous experiences in science, but also just your whole life. Like, what are the things that you choose to do when no one is telling you what to do? Because in science, nobody's going to be telling you what to do a lot of the time. And so you should pick stuff that just compels you to do it because you enjoy it so much. But by the same token, you want to make sure that there are also things that are part of the mix of requirements for your project that stretch you, because there may be things that you don't know that you like. You don't want to narrow what you're willing to do just based on sort of what you know about yourself already.
My deep interest was in puzzle solving, codes and decoding. And I didn't really know what form that would necessarily take. Somehow I was convinced that understanding the brain would be mathematical, that somehow mathematics would be revelatory of what was going on in the brain. And when I started as a biology major at Cornell University in 1984, I kept hoping that my biology courses would take me to something mathematical that would somehow reveal some key underpinnings of the brain. I had no idea what specifically I had in mind. Finally, in my junior year, actually, I got to a course called Animal Communication, which when I heard about it, I thought it might be something like dog ESP. I didn't know what animal communication would necessarily be, but a friend told me that it was offered at the right time and it might be possibly a good course. But it turned out to be a course about how organisms respond to the physical signals in the outside world, like light or sound or chemicals that are odors or chemicals that are tastes. And all those physical signals would be transformed into electrical signals that then would be processed by the brain, and then the organism could respond to those signals in an appropriate way. And to me, this was the secret of life. Suddenly, he was showing us how the inanimate physical world was transformed by the brain into the electrical signals. This was the ultimate code. And that's when I realized I want to study something like this. How do I find out more? I just wanted to get the same lecture over and over again, like a favorite bedtime story. And so I discovered an area of research that was nothing like anything I could dream about before discovering it, through paying attention to something that I didn't necessarily think was going to be interesting. It was by being willing to take a class that I didn't really know anything about, ready to hear what this professor had to teach me. By that process, I was able to discover something that I found fundamentally exciting.
And so some of those things you might discover along the way as you do your own project, like something is really fun for you or something sort of uncomfortable for you. And so you may or may not know these things as you get started. I mentioned earlier that I really love microscopy. Like, I have a unholy tolerance for sitting in a dark room by myself, staring at tiny fluorescent glowing things and listening to music. Like, I am happy doing that for days on end. There are other people who are not, right? And so you should accept the sorts of modes of things that you like to do. I have students that have an unbelievable mind for genetics, which I do not. It is so abstract for me. Like, I'm a biochemist at heart. I like to take the purified things and mix them in a tube and see what they do, right? Genetics is a much more abstract reasoning exercise that does not come easily to me, but comes very easily to some people in my group, and they're extremely talented at it and love it. Finding these things that sort of resonate with you and making sure that there's some piece of them in your project, it's like exercising your talent, right? In my mind, it's less important what you work on than how you work on it, and that you come out of your experience as a graduate student inspired and enabled to go do amazing work.
Everybody has a different skill set and a different way of thinking that can make them successful in different ways. And so there's no across the board tips really, except for I would still drive home the fact that you need to be motivated and you need to be interested. For me, even though I have 2 kids and my time in lab is restricted between 9 to 5, you still think about science when you're outside of work. You think about it at night, and that type of interest and that type of motivation is incredibly important. And so it comes down to you just pursuing what you're really interested in, and knowing that research is the most important thing for you.